We want to continue on our study of functions and where they are positive and negative. In our last video, we were asked the question of where a function was positive or negative given its graph. Well, we could also be asked that question if it's given as a formula. So let's say we have the formula f of x equals negative 2x squared plus 5x plus 12 as our function. And I asked you, where is this function positive? Well, that would be equivalent to, so let me write that question down, where, and so where meaning for which x values, is this function positive? All right? Well, it was pretty easy or straightforward to determine where a function was positive if we had its graph. So what I would like to do is to take this function and create its graph so that I can then read off the information from the graph. So the first thing you ought to recognize that this is a quadratic function that you have seen before, which means it's either a parabola up or a parabola down. We know from this sign on the lead term that this means our parabola opens downward. So this should be what our graph looks like. Okay? Now, knowing that this is the shape of our graph, and then it goes upside down, what we need to do now is find the places where it crosses that x-axis. Remember, find those points of interest or our zeros. So what we're going to do is we are going to first find the x's such that f of x equals 0. Okay? And we're going to do that, move this on up here, by taking our formula, minus 2x squared plus 5x plus 12, and we're going to set it equal to 0. Now, if we're lucky, this quadratic factors. And guess what? We are. Minus 2x minus 3 times x minus 4 equals 0. Of course, you can check this by remultiplying, and if you remultiply, you should land back at that original function. Okay, so now that we have our function or our quadratic in factored form, we know that the product of two factors equals 0 if and only if at least one of our factors equals 0. So I find out by setting each factor to 0, and I solve for the x that make that true. So minus 2x equals 3, x equals negative 3 halves. So when x equals negative 3 halves, this factor equals 0. So regardless of what this factor equals, the product is 0. Or x minus 4 is the one that is equal to 0. And that happens when x equals 4. So if x equals 4, this factor is 0. It doesn't matter what that factor equals. The product will be 0. Okay? So using the information of our zeros and the shape of our graph, we get a lot of information. So let me push this up a little bit. Good. And so let's plot, or let me use the black one again. Let's see if we can do a quick sketch of our function. So when x equals negative 3 halves, our function is 0. When x equals 4, our function is 0. Now, we know, and there's other information that we could find. We could actually find the vertex of the quadratic. We could find the place where it crosses the y-axis. But for this problem, we don't need to. We just need a general sketch. So we know it comes up, peaks, comes back down. We know this because it's a quadratic, so it's the shape of a parabola. We know it's upside down because our lead coefficient is negative, and we know that it crosses at these zeros because we solve for the zeros up here. Okay, so now we're reduced to answering the question of where my function is positive by looking at the graph. We know this is negative 3 halves, and this is 4. So it's pretty easy to answer the question. Between negative 3/2 and 4. So that's interval notation. We could also write it this way. X is less than 4, bigger than negative 3/2. For these x values, f of x is positive. Okay? I could ask you, well, where's the function negative? You would say, that's easy. It's for all x values to the left of negative 3/2 and all x values to the right of 4. So if we write that, we could write it in interval notation. Negative infinity up to negative 3/2. Remember, we don't include that endpoint unless we want it to be also where it is equal to 0. And everything from 4 on to positive infinity. We join those by a union sign. We could also write this way. X is bigger than, x is less than negative 3/2, or x is bigger than 4. For these x values, f of x is less than 0, and that is negative. So to find out where a function is positive or negative given the formula, one method, if it's easily done, is to first sketch the graph of the function and then find out where it sits above and below the x-axis.